Hello and welcome to Mr. Wiley Teaches Math. Today we're going to talk about scientific notation and large numbers. In science and geography, we often come across very large numbers, things for areas, distances, and there's got to be a nice short way to write them. So we often use scientific notation or using powers of 10 to help us write this out. So 9,700, we would change this to 9.7 times 10. We have to think about how many times we move the decimal over. Our decimal started here. I've shifted over 1, 2, 3 times. So it's 9.7 times 10 to the power of 3 would be how we'd write this in scientific notation. With a small number like that, it's not too important to write like that. It's probably more writing, but when we get down to some of these larger ones, it'll save us, make it a little bit cleaner and neater to write. In this case, 8,430, I still want to have the decimal after the first significant digit, the first number that's not a 0. So it's always going to be number decimal than the rest. So this is going to be 8.43, and I can leave off the 0, times 10 to the, how many times did I move it? 1, 2, 3. So this is 8.43 times 10 to the power of 3. Okay, this is 4,250,000. I'm going to write this as 4 decimal, the other significant digits, 2, 5, leave off all the zeros, times 10 to the, think how far I moved it, 1, 2, 3, 4, 5, 6. I moved the decimal 6 times to the left. So it's 4.25 times 10 to the power of 6. In this case, I think we have 14,625,000,000. I would write this as 1 decimal, and then the rest of the significant digits, 4, 6, 2, 5, and I stop there because the rest are all zeros, times 10 to the, how many times did I shift it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, times 10 to the power of 10. So in this case, it's getting much cleaner, and if I wanted to do this even if it had been simply 9,600,000,000, it would have been even cleaner because it would have been 9.6 times 10 to the 10. 9 in that case. 1 too far. Sometimes we're going to have to write it in standard form. We're going to have to take our scientific notation. We're going to have to write it out in standard form. So this is 8.3. So I'm going to write my 8.3. And I know I have to move the decimal 4 times. So I'm just going to write some zeros after it. If I don't need them, I don't need them. That's all right. So 8.3 times 10 to the power of 4. My decimal started here. I'm going to move it 4 places. 1, 2, 3, 4. So the answer is 83,000. I don't need those zeros. All right, 9.2 times 10 to the power of 7 is scientific notation. I know it's going to be 9, 2. I'm going to have a bunch of zeros. I have to move my decimal place 7 places. I'm starting here. So 1, 2, 3, 4, 5, 6, 7. So I end up with 92 million. I'll write it in with proper spacing. 6.54 times 10 to the power of 8. So I know it's going to be 6, 5, 4, and then a bunch of zeros. And I have to move it 8 times from its starting location. From here, 1, 2, 3, 4, 5, 6, 7, 8. So we are at 654 million. In this case, it's 7 and 2 10/100,000ths times 10 to the power of 6. So I have to write these zeros because there's a significant digit on the end, the 2. And then I'm going to have the zeros that I'm not sure how many I'm going to need. So I'm going to start my decimal place here and move it 6 to the right. So starting here and going 6, 1, 2, 3, 4, 5, 6. I end up with 7 million 2000. So scientific notation helps us write really large numbers in a form that doesn't have a whole lot of zeros tacked on the ends. Thanks for watching. Be sure to check the class website for additional examples, the handout, and assignments.